If you look up at the clear night sky, you might see a few sparkling dots in the darkness. Those are Venus, Jupiter, and maybe even Saturn. But there's one planet that will never appear before your eyes. It hides beyond human sight, smaller than the icy planet, yet farther away than any other planet. That plane is Neptune. A planet of impossible storms. Of winds howling faster than sound. Of faint icy rings swirling in an eternal twilight. And moons that whisper of a fierce, forgotten past. It is the most mysterious planet in the solar system, the one we understand the least. But how did we discover such a distant planet, hidden in the cold darkness? The answer didn't begin with a telescope, but with mathematics. In 1846, French astronomer Urbain Le Verrier noticed something strange about Uranus. Its orbit didn't quite match the delicate laws of universal gravitation defined by Newton. Something invisible was tugging at it, a force beyond the known planets. So Le Verrier did what few dare to do. He calculated the position of a planet no one had ever seen. He sent his prediction to his friend, Johann Gottfried Galle, in Berlin. And within just 1 hour, a faint blue dot appeared exactly where Le Verrier had said it would be. That night, humanity met Neptune, the only planet ever discovered through the pure power of mathematics. Just a few days later, its largest moon, Triton, was discovered. But soon after, Neptune drifted back into the shadows, orbiting at the very edge of the sun's influence. At its farthest point, Neptune drifts even beyond Pluto. From its surface, the sun appears as a tiny bright disk, 30 times smaller than what we see from Earth, giving off only 1,000th of the light we receive. Because of this immense distance, the planet remained just a faint blur through telescopes for centuries. It lies 4.5 billion kilometers from the sun, 30 times farther than Earth. With modern technology, reaching it would take 13 years. And since its discovery, Neptune has completed only a single orbit around the sun. One Neptunian year lasting 165 Earth years. For decades, it was a world out of reach until a rare opportunity appeared. In 1989, Voyager 2 became the first and only visitor to Neptune. 3 years after bidding farewell to Uranus. Voyager turned its cameras toward the deep blue horizon. beginning its final, greatest journey toward the silent, storm-racked world at the edge of the sun's influence. After 3 long years of traveling through icy regions of space, Voyager 2 finally arrived. From the darkness emerged a pale blue sphere. This was Neptune. These were humanity's first real images of this mysterious planet. Its rings shimmered faintly under the weak sunlight, and a cluster of previously unknown moons orbited in perfect, silent harmony. But what Voyager saw next surpassed all expectations. The atmosphere is unimaginably cold, averaging minus 201 degrees Celsius, with an axial tilt of 28 degrees, similar to Earth or Mars. Neptune also experiences seasons, each lasting about 40 years. Currently, the southern hemisphere is in spring. Even though the sun is over 900 times dimmer than on Earth, its light is enough to warm the sky to around 10 degrees Celsius. Releasing frozen methane into the stratosphere. Bright patches emerge from space, while the rest remains trapped beneath the deep ice of the troposphere. Beneath the brilliant blue lies a stormy world of hydrogen and methane. Hydrogen makes up 80% of the atmosphere, but it is the 19% methane that gives Neptune its signature blue hue. Voyager 2 recorded wind speeds reaching up to 2,160 kilometers per hour, some blowing against the planet's rotation, nearly supersonic. No one had ever imagined such fierce winds. Amid these raging winds, Voyager 2 discovered a giant. The Great Dark Spot GDS 89, a storm the size of Earth, violently swirling through Neptune's upper atmosphere. Much like Jupiter's Great Red Spot, it rotates counterclockwise, with gusts reaching 2,400 kilometers per hour, making it the fastest winds in the entire solar system. Voyager also spotted a smaller storm, the Small Dark Spot, drifting south of the colossal storm. As the spacecraft approached, this smaller vortex mysteriously faded from dark to light, as if vanishing into the clouds. Years later, the Hubble Space Telescope continued the watch. Astronomers were eager to find out whether Neptune's storms lasted as long as Jupiter's. But when Hubble observed in 1999 both dark spots had completely vanished. New storms formed only to fade away again. One appeared in 2015, lasting a few years, then disappeared as well. It seems that Neptune's storms live, grow, and vanish in a continuous, ever-changing cycle. Scientists believe this planet may have atmospheric bands similar to Jupiter's, though fainter and fewer in number. As these bands move at different speeds, they can create massive vortices where they collide. Once formed, a storm can drift across the planet until it moves away from its energy source, then slowly fade back into the deep blue methane clouds. Hubble remains our only window to observe these fleeting storms. As they are nearly invisible across most wavelengths of light. Only in the ultraviolet spectrum can Hubble see deeply enough to track the evolution of Neptune's atmosphere. But there's still a question. If Uranus and Neptune are similar in size and composition, why is Neptune's atmosphere so violent? While winds on Uranus reach only up to 900 kilometers per hour. The sun's weak influence cannot fully explain this. Something deeper is driving the chaos. A hidden power beneath Neptune's icy exterior. And this is one of the greatest mysteries. How the farthest planet from the sun, shrouded in eternal darkness, can blaze with relentless energy. Neptune radiates heat from deep within, while Uranus barely emits any warmth at all. Scientists believe that billions of years ago, Uranus collided with a massive Earth-sized object, a violent impact so intense that it stripped away nearly all of its internal energy. This could explain why Neptune, still holding on to its primordial heat, boasts far stronger storms and a far more turbulent climate. But what exactly is Neptune made of? Beneath its thick gaseous layer lies a vast, slushy mantle surrounding a solid core. In regions where pressure exceeds 7 million times that of Earth, methane is crushed into pure carbon. From there, a diamond rain falls through the mantle, possibly even forming liquid carbon oceans, where chunks of diamond float like icebergs. It's all still hypothetical. But modern experiments are beginning to replicate these extreme conditions. Neptune's magnetosphere hides yet another mystery. Its magnetic field is tilted by a staggering 47 degrees relative to its rotation axis, more than any other planet. At first, scientists thought Uranus' tilt was due to its sideways rotation, but Neptune, spinning normally, exhibits the same bizarre feature. This suggests that the magnetic field does not originate from the core, but from the electrically conducting liquid mantle, or that the mantle itself distorts the field, creating the tilt we observe. The magnetic field of every planet is slightly tilted relative to its rotation axis, even Earth, but Neptune and Uranus belong to a different league. They also have auroras, but not the bright, colorful bands we see on Earth. Instead, the light is faint and ghostly, appearing only as quiet arcs within the upper atmosphere. These auroral bands, invisible to the naked eye, can only be detected with instruments, serving as a reminder that these planets still hold many secrets yet to be understood. No story of Neptune would be complete without its children. So far, we know of 14 moons, all named after sea deities from Greek mythology. The 7 closest moons are regular satellites, orbiting Neptune's equatorial plane in smooth, circular, and stable paths. Farther out, where orbits tilt and stretch, lie the irregular moons, silent wanderers of the system. Among them, one stands out above all, a retrograde world named Triton. Triton, Neptune's largest moon, is a world of paradoxes. Unlike most large moons in the solar system, it moves in the opposite direction of its planet's rotation. Neptune spins counterclockwise, yet Triton orbits clockwise, tilted an astonishing 130 degrees. This retrograde motion is a confession from the past. Triton was not born alongside Neptune. It was once a captive. A wandering world, perhaps once a dwarf planet, pulled into the immense gravity of the blue sea god billions of years ago. Today, Triton dominates Neptune's satellite system, accounting for a staggering 99.5% of the total mass orbiting the planet. To put it in perspective, only Earth's moon is more tightly bound to its planet. Though slightly smaller than our moon, Triton appears almost the same size in Neptune's sky. It is the 7th largest moon in the entire solar system, and astonishingly, even larger than Pluto. Pluto is often regarded as the ruler of the Kuiper Belt, the icy frontier of the solar system. But perhaps that title once belonged to Triton. Before being captured, Triton may have truly been the giant of the Kuiper Belt, an independent world ruled by ice and darkness. When NASA's New Horizons flew past Pluto in 2015, it revealed astonishing similarities between the two worlds. Identical compositions, matching surface materials, and the same cold, stark beauty. They could very well be siblings, born in the same region, torn apart by fate. But how did Neptune manage to capture such a massive body? For an object to be captured, it must lose enough energy to avoid slipping past the planet's orbit. The most widely accepted hypothesis is that Triton once belonged to a binary system, much like Pluto and Charon. During a close encounter, Neptune's immense gravity tore the pair apart. One object was flung into the endless darkness, while Triton, losing just the right amount of energy, fell in, forever bound to the blue sea god. A perfect capture, written in the cold, unyielding laws of gravity. The connection between Triton and Pluto runs deeper than tales of origin. Both boast surfaces rich in nitrogen ice, mixed with traces of water and carbon dioxide. Triton's terrain is strangely flat, rarely varying by more than a kilometer. It's etched with ridges, grooves, and plateaus, silent traces of internal forces quietly reshaping this frozen world. The surface of Triton shows almost no impact craters, a sign of a geologically young world, constantly being renewed. Scattered red patches mark the presence of tholins, complex organic compounds formed when methane is broken down by ultraviolet light. They are not evidence of life, but they are the building blocks in the chemical journey toward it. Even in its stillness, Triton harbors creative potential. Beneath Triton's frigid crust lies another world, a dense core of rock and metal. Radiogenic heat from it could keep part of a subsurface ocean in liquid form. Like Europa or Enceladus, Triton might harbor a hidden sea where water exists and perhaps where microbial life was once sustained. This internal heat doesn't just create mysterious oceans, it also drives icy eruptions that continually renew the surface. Ice volcanoes, cryovolcanoes, blast plumes of water vapor and organic compounds into the sky, freezing instantly. They leave behind bright plains called planitia, solidified lava lakes of ice. Depressions, remnants of collapsed volcanic vents, mark where violent eruptions once occurred. Minerals from the depths are brought to the icy surface, forming organic compounds, a sign that, even in its silence, this world might still be alive. Images for Voyager 2 reveal Triton's surface scarred with long, straight grooves, likely caused by tectonic shifts or cycles of freezing and thawing. Some regions bear marks of dark streaks stretching hundreds of kilometers, remnants of relatively recent eruptions. This world, seemingly motionless, is in fact breathing. Although they resemble volcanoes, Triton's eruptions are an unusual phenomenon. When Voyager 2 flew by, it recorded nitrogen gas plumes nearly 8 kilometers high. But these don't originate from a molten layer. They're driven by sunlight. Imagine a transparent layer of nitrogen ice covering darker material. Weak sunlight penetrates the ice, warming the material beneath, causing it to sublimate into gas. Pressure gradually builds until the crust cracks, ejecting nitrogen gas and dust into the sky. After each eruption, the dark material falls back, covering the surface and starting a new cycle, much like what we've observed in the polar regions of Mars. For these eruptions to occur, Triton needs something rare, an atmosphere. Thin, so thin that its pressure is comparable to what you'd feel at 80 kilometers above Earth, but it still exists. Like Pluto, Triton's atmosphere thickens and thins with the seasons. Since Voyager's visit, it has grown slightly denser as surface ices warm, sublimate, and form its very own sky. At the time Voyager flew by, Triton's atmosphere was active enough to sustain weather up to 8 kilometers high. In the images, you can see faint clouds drifting across the pale horizon, along with elongated dark streaks. evidence of steady winds sweeping through the thin air. Like Pluto, Triton's atmosphere glows with a faint, ethereal veil. The continuous cycle of icy eruptions, sublimation, and settling organic dust creates a vivid rhythm of activity. Triton isn't just an ordinary moon. It's a miniature world, a frozen mirror of Pluto wandering at the edge of the solar system. But Triton is not alone. Behind it lies Proteus, the second largest moon of Neptune. Unlike many other moons, Proteus is irregular, angular, and rugged. With a diameter of over 400 kilometers, it's larger than Saturn's moon Mimas, yet never achieved a spherical shape. Craters over 100 kilometers wide reveal that Proteus endured colossal impacts, leaving its surface fractured and chaotic. Closer to Neptune, the so-called shepherd moons weave through the ring system, keeping dust particles in place. Farther out, the irregular moons drift along tilted, chaotic orbits, held captive by Neptune's gravity. Some orbit in the same direction as the planet. Others go the opposite way, their paths winding like an intricate dance in the darkness of space. The two outermost moons, Psamathe and Neso, orbit Neptune at an immense distance, taking up to 25 years to complete a single revolution. They're the most distant moons ever known in the solar system. Neptune's enormous hill sphere, an invisible gravity bubble, keeps these moons in place, even at the edge of darkness. In 2013, Hubble discovered a new small moon, Hippocamp. Unlike independent worlds, Hippocamp was once part of Proteus, torn away by a cosmic collision. Today, this 35 kilometers fragment quietly orbits its mother, a frozen relic of a violent past. And beyond its moons lie strange objects outside Neptune, like 2020 VN40, dancing in resonance with the planet, completing an orbit every 10 Neptune years. The planet of deep blue storms and hidden power remains one of the least explored worlds. Only Voyager 2 has ever visited. Since then, we've only glimpsed it through distant telescopes. Its atmosphere, mysterious core, and moon systems still hold countless secrets. No new official mission has been launched yet, but there are flickers of hope. China plans to send a probe in 2033. If successful, who knows what wonders await? Neptune, the final, distant, wild, and hauntingly beautiful planet, is a reminder that even in the coldest corners of the universe, there are worlds waiting to be heard.